Good morning, everybody. Today I woke up for a LeetCode contest. Let me close that, open that, and show it to you. So yeah, we have a LeetCode contest today. I don't know, I'm very sleepy. Somehow miraculously, last time I got positive rating change, so even for finishing outside of top 100, so let's hope that today won't be worse. I will be already happy with that. Let's hope we just don't do stupid mistakes and everything goes fine. Honestly, this looks promising. Given a binary string s, return true if the longest continuous segment of ones is strictly longer than the longest continuous segment of zeros. I'm not... okay. Longest 0 equals longest ones equals 0. Current equals 0. In S. Oh, that's current. Current character equals, I don't know, something else. If character is equal to current character, current gets incremented by 1. Else, if current character is equal to 0, longest zeros gets maximum of longest 0 and current. Else, if current character is equal to 1, longest 1 gets maximum of longest 1 maximum. Current gets 1, current character gets character. I feel like we need these two guys at the end, and then return longest 1 is strictly greater than longest 0. So we have true, false, and then false. Looks reasonable. What the? Wait, what? Why? Oh my goodness me, how am I that stupid? On the first problem, what am I doing? Oh. Wait, it's not... oh. Honestly, I just plunged it. Okay. Whatever, just so stupid. Okay, minimum speed to arrive on time. We are given a floating point number r representing the amount of time we have to reach the office. To commute to the office, you must take n trains in sequential order. You also given an integer dist of length n, or dist r describes the distance in kilometers of the ith train, right? Okay. Each train can only depart at an integer r, so you may need to wait between each train, right? Okay. For example, if the first train rides... okay. Minimum positive integer speed in kilometer per hour that all the trains must travel at for you to reach the office in time, or -1 if it's impossible to be on time. Answer will not exist. Or will have it must. No, it's clearly binary search. if can reach within middle, I think that, no, actually, I assume that speed of 0 is never good. I think so, at least. And here we just want to simulate the entire process. But time we will spend is equal to distance over, okay, for distances current time starts at 0, times gets incremented by distance over speed. But it's like very I don't exactly believe in this. We'll have to rethink about how it works. So, no, that's like, ideally that's what you want, but then like this, I don't trust this floating point arithmetic. So one thing I can do is use this, and instead of ceiling, taking the ceiling, I'm gonna say like I think this is equivalent. Here R has most 2 decimal digits. Still sounds very questionable. 1 to 2, no, like here it's already -1. Why is that? I assume because speed didn't work as we expected. Yeah, I do agree. Maybe I should have done just this. No, it still doesn't work. Oof. Just so stupid. Okay. How can one person be that stupid? If you know the answer. Oh, we don't even have that variable here. Why am I parenting it? Or maybe I should increment by distance times speed. But no, like I already did it, right? Oh, time is in the different units, right? Okay. We actually want this. No, that's useless. Okay. Four. Why? Why 4? Let's think. Time will be a multiple of speed. Time is always integer. Oh, because it's a multiple of speed, right? So. No? Okay. That's really not what you expect. Okay. Not exactly understand. Why do we have it here? Oh, because the last time we don't have to round. Because the last time we don't have to round. So frustrating. What do we do last time then? This corresponds to rounding, right? So without rounding we would have something like this. No, actually like this. Right, but we don't want to divide by speed, so we'll say like this and return the results of this comparison. I don't know, at least it matches the sample. So like for every train in between we have to wait, and therefore we convert to integers with that strange way. And at the end we just check this. I'm a bit concerned with R being a float. It just sounds terrible. I'm quite concerned about this, the precision of this algorithm, but like we're already losing this contest. You must be, what? That's just, okay, that just completely lost contest. Now, of course it has to do with this, like, what else did you expect? Okay. I don't know, can you just do something like this? Oh, I believe like this is actually the safest way to multiply. Yeah, now we get the correct answer. How interesting. Don't tell me we get TLE this time because we're using Python. No, okay. Still terrible, but whatever. It's about solving problems either way, not about not being sleepy. Like on actual entry you won't be sleepy, right? You're given a zero-indexed binary string s and two integers min jump and max jump. In the beginning you're standing at the index 0, which is equal to 0. We can move from index I to index j if the following conditions are fulfilled. J is between this and sj is 0. True if we can reach index in s, otherwise false. Okay. But that's like, okay, I mean, I don't mind. Let's think. In range n. Okay, what are if I is at least m, like, of course you have to consider backwards, and we'll have a window which says like, I actually want to count how many occurrences are reachable in that window. If it's at least one, then we are good. If a is at least m, if dp at I minus m, then I assume that we should decrement it. And if we, then dpi gets true. False, false, doesn't look promising, because here the answer is true. The idea is that you count the number of truths of reachable cells in the window, and then the window is sliding. Oh, and we also have to check that current index is 0. If s at I equals 0 and v, then dpi gets true. I also think that we should print it here. So here we don't have anything in the window, here we still don't have, here we have one reachable thing, but it's not here. For I equals 3 we decrement. I think that we decremented m plus 1, so I think this is how it goes. true, false, false, because it's 1, 1, then true, false, true. Okay. Here we have true, false, false, true, false, 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 and then false because window is not long enough. Sounds very reasonable. True and false? I don't know. Okay, at least we get it somewhere. Stone Game 8. Alice and Bob take turns playing a game, Alice starting first. There are n stones arranged in a row. On each player's turn, while the number of stones is more than 1, they do the following. Choose an integer x at least greater than 1. Remove the leftmost x stones from the row. Add the sum of the removed stones value to the player's call. Place a new stone. They will do the following, so they do all the things. Place a new stone whose value is equal to that sum on the left side of the row. The game stops when only one stone is left in the row. The score difference, Alice's goal is maximize the score, and Bob's to minimize, returns the score difference. Okay. Whoa. We have a lot of stones here. Also, it may not be beneficial to just take all the stones. What? Oh, because stones can be negative? That's interesting. Oh, okay, we're taking prefix sums, and after we took them, we can only take larger prefix sums. So there should be a DP to this. DP will have 2 parameters. We're interested in the first player and then first entry. I'm pretty sure we want to compute from the back. Okay. So what would we like to do here is like DP add 0, I gets what? Alice wants to maximize, so this should be her goal, I suppose. Score of IJ plus this guy. To J. J in range from I to M, from I plus 1 to M. Now we have to optimize this somehow. Knowing that score is the sum of these guys. How do we actually maximize this? Okay, so it's like what? It's, if you don't mind, it's from AI. No. It's just PJ. It's just PJ. Zero. Okay. Wait, is it PJ actually? No, I think it's PI, just PI, and then we don't care at all. And then just M1, I don't know. I have to think a bit more careful about this one. Well, first of all, I think like this. P1. It looks like we're going for a minimum. So minimum of 0 minus PI, because PI goes to... No, here Bob will minimize, here will maximize. Here minimum will get minimum. That's why I imagine, at least. Oh. -3, -3, doesn't look like it. Why? Or is it PJ, actually? No, I think it was PJ, And M0 is the best that he can get. No, M0 is from PJ. So it's like DP1J minus this guy. So it makes perfect sense to say that we actually want to store M0 in such formats. It's how much we can get if the previous turn was Bob's. That's what I imagine. And here it's M1. Is it like this? No, it still doesn't look like it. Let's think. What does it, like we are currently at index I, it means that we can choose any sums that is at least I long. Oh, can we do it like in this order? But then if pi is equal to, if I is n minus 1, pi is valid number. Oh, it doesn't change anything? Okay. Oh, we have 3 guys here. Okay. It's not difficult to fix. So actually we get zeros all the way. That's not smart of me. But no, I always assign here, so I select no. Although I think that it should be actually like minimum should be infinity and then maximum should be negative infinity, so that we take these values actually. Is it getting? It's not getting better, okay. Maybe we want actually this. Take this. Okay, let's just pause for a moment and think. So dp 0i is maximum score that Alice can get if she starts at position I. What is it? It's maximum of dp1j plus pj prefix sums to j. So we take sum to j's element for j in range from I to n, from I plus 1. N inclusive. So therefore we save such things to M1, and we say that your score gets M1. Wait, why actually M gets M1? Not the other way around? Okay, Alice clearly wants to maximize this actually. 0 and 1. Okay, I completely messed that up. No, wait, still, we're getting in this same situation. Alice wants to maximize these guys. This is a score for Alice. And 5, 13, 12. That's not the answer, but only in the last test case. 12. How did we get 12 on ours? But actually, oh, because we can't take one element, right? Right. But we never take just one element, do we? Feel like we don't. 12, negative 12, negative 22, 0, 22. So if Bob is at the second element, but no. I think that the length of the game is actually one smaller. If you're already at the end, then you don't care, kind of. Does it has to happen after? Oh no, actually, no, at the last index we don't do anything, right? And we assign something. Oh, probably because it's too good, right? M1 should be minus PM, and M0 should be minus PM, and M1 should be PM. No, still not getting it right. But no, like at the very end index, we don't have to take anything. That's the trick. That's the trick. The length of the game is actually one smaller, so the last values should be zeros, right? One is not the correct answer. Actually. So like this, if we are in this position, then this score we can get is 0 because the game already ended. And if we are in this position, then we should consider all possible options for j. We do consider them in these variables. Is it because pi is wrong? Pi plus 1. Should I take pi plus 1? 5, 13, negative 22. Looks promising. I'm more or less willing to submit it and forget about this contest. Okay. So we finished terribly badly because we have 2 wrong submissions. We actually haven't finished for the next 10 minutes. And it's been already 40 minutes. So 50 minutes penalty, it's now no way to getting into 200. Yeah, just terrible. No, actually, well, we're still not getting anywhere near. Yeah, you can see all normal people just submitting everything very quickly and without bugs on the first 2 problems. So I doubt that there's any chance that we will get anywhere good with our penalty. But hey, That's fine. Or maybe we'll still stay in like top 150, potentially. I guess that's a very just the right song for this moment. When you completely waste the beginning of the contest, but then you come back a bit. Obviously, that's very slow for such a simple DP, but hey, like I legit woke up like 20 minutes before the contest, so it's fine. I still had fun, like as compared to previous contests, I actually think that this time like all our mistakes were on me and not on like stupid time constraints which don't suit Python or anything like that. So that's completely fair. That's how I feel about this contest. Probably it won't help me a lot in terms of places. Yeah, like a lot of people will just finish now of those guys. Like, come on, he must be able to solve simple DP during the next, I don't know how many minutes. So yeah, we should wait at least 8 more minutes before we know our place. Judging the number of people who... Oh, no, okay, just relatively little people finish without bugs. That guy had a tough afternoon, probably. He's stuck. Yeah, just you see, you solve everything without bugs, and you're cool. And that's the plan. Too bad I can't implement it. Okay, no, it was actually fun. Apart from first, Q2 is harder than usual. Like honestly, binary search where you have to worry about precision, that is not something you see as a Q2. And then just 2 DPs, like you can tell yourself how interesting these problems are based on the indices, but whatever. Yeah, and the other thing I have in mind is of course this. And that's like literally me when when I completely waste the beginning of the contest, but then still somehow get positive rating change. That's just this. I cannot turn the music on because it's obviously copyrighted, but just turn it on yourself and you will get the feeling. Yeah, we're slowly sliding down the order. But that's fine, that's fine. Our guy is having a tough time with that problem. I don't know, like Dead Rabbit is actually really strong. Andrew is also not bad. Well, I also took 20 minutes to implement obvious DP because I confused myself like a million times about what should be maximum, what should be minimum, at which index you should take prefix sum. These details are not what you want to think. It's just... I feel like it's worth explaining our approach to Q4. Not the specific solution, but how to think about DP problems in general. Oh, we ended up not using infinity. Okay, that's actually good. You just write what is the score of the person in each case. Like, you know that you need to make some observation about the score of the move, which in our case is just prefix sum. And you think like, okay, prefix sums are increasing. The range over which they are taken is increasing. So you do have to like your state is player figures now, and then length of the prefix that you already merged. And it's natural to consider positions backwards, because like if you think about states, what is the easiest state? Then it's actually when the game has already ended. I'm telling you, like if the game has already ended, then you can compute what is the score difference that you can get after this position. It's 0, because the game has already ended, right? Then you just compute backwards. Taking minimum, you know that Alice's score is maximum of some expression, Bob's score is minimum of some expression, and the trick is because these minimums and maximums are in some way like sets over which you take maximum and minimum. They form a monotonic chain, so every next set is included in the previous set, and therefore you can compute maximum as you go by adding one element at a time. That's exactly what you do in half of these problems. In other half of these problems, you're doing something even simpler. I don't know. And also with Q3, it was also the trick. So here the thing was that we would like to, like in math, we just had a formula here. That dp at 0i was maximum of some expression. And then you just had to store this maximum in a variable and compute it as you go. Very, very natural. Yeah, I'm kind of waiting until 6:19 in the morning to get our final place. So I have time actually to explain this one as well. Here again, you want to say like if any element in range between this and this is true, then we want to set the current element to true. And then you just think like, okay, how do I compute ranges? Well, ranges are do not form a monotonic chain, but they form something relatively simple. It's a sliding window, right? So just take your window, slide it, and here you go. The only thing you have to worry about is to actually have to subtract at n+1. But I didn't want to check it like explicitly in both cases because I used it twice, so I just added one to it here. Yeah, usually with this problem, with a lot of interview problems, the trick is that you want to start with something stupid. Something that works from mathematical point of view, but doesn't work quite fast enough from the coding point of view. And then you want to find some expressions that form a pattern. Either it's a sliding window, it's a monotonic chain of sets, some patterns. Just you don't have to find the patterns that I find, just find the patterns that you remember from previous problems. And like usually several values in the problem or one value, they can be computed in several different ways based on what do you take as your reference point. Usually what's given in the problem is the wrong reference point, and you have to rotate the statement of the problem around that reference point to get a better standing point of view. That's like very abstract way that I think. Like I think that we have a problem. We can't compute any of range quickly. How do we do it? Oh, like we just have to use the similarities between consecutive ranges, that they differ at most by 2 elements. That's what I do. There I have like maximum, minimum. I cannot compute maximum of range quickly, so we have to use some property of all maximums that I want to compute. Usually you cannot speed up one computation, but you can speed up a chain of computations if they have some structure. And you're just looking for the structure, and if you are good to recognizing patterns, and you should be used at problem solving. Okay, it's 6:20, so 50 minutes in the contest. I believe that our rank should not change after this point. Okay. Oh, actually, our guys having a tough time. I know what's happening here. You just don't know these guys, so you don't know how smart they are, but they are very smart. Like, they both have more experience than I do in competitive programming for sure. Like, because in the high school I was doing math Olympiads and the guys were doing serious competitive programming. So, bro, like, there should be no way that I'm winning. Especially with 2 bucks, but whatever. Like, everybody can have a bad day. Let's hope that next time we all get better luck. Because obviously 81st place is not where you want to be. But I did take a lot of time just solving problems. Like, even if I finished without penalties, it would have still been a disappointing 47th. Whereas Isaac can just get everything right in 30 minutes, so... Obviously I spent some time debugging here and more than necessary time debugging here. So it was possible to finish in 30 minutes for sure. Just me being too sleepy. But hey guys, I had to make content for you, so it's fine. It was also fun. In some meaning of that word. So yeah, see you later tomorrow, I guess. And definitely let me know if you have any questions in the comments below. You can always join my Discord server, blah blah blah. You know the drill, right? So, bye.